Welcome, listeners, to Cyber GPT Pulse podcast. This podcast where we dive into the nitty gritty of container orchestration, the Kubernetes, the K8s. So I'm your host, Mohammad Ilyas.
I'm your co-host Amir. Indeed, Ilyas. So let's embark on this journey together. For those tuning in who might be novice in the world of Kubernetes, could you paint a vivid picture about Kubernetes, what exactly it entails, and why it has emerged on a pinnacle of innovation in the realm of technology?
Absolutely, Amir. Kubernetes often referred to as K8s, which is an open source container orchestration platform designed to manage containerized workloads at scale. So it abstracts the complexities of infrastructure management, allowing users to develop, scale, maintain applications with ease. So later we will also discuss some key technical concepts with Kubernetes in a few. So breaking down what makes this technology a powerhouse in the world of container orchestration.
Indeed, Ilyas. So let's start with the basics. What can containerization and what is containerization and why it is so crucial with context of Kubernetes?
A great question, Amir. The containerization is the process of encapsulating applications, their dependencies and configurations into lightweight portable unit called containers. Kubernetes solely relies on containerization technologies like Docker to ensure consistency across environments and to simplify the deployment process. Um,
Yeah.
this approach allows developers to create applications that can run anywhere, where it is a developer laptop or an on-premises data center or even in the cloud.
Sure, Elias. So that's basic, simple enough definitions. So let's further break down the container cycle, which actually gives some idea where exactly Kubernetes plays the role in that. So the container life cycle has a few phases. The first phase is pre-commit version control, where the developer writes the code and commit it into any version control. Could be GitHub, and this any vendor of GitHub is just one vendor of Git. So this step tracks change and allow collaboration among multiple developers. And second stage is acceptance testing. When once coding is committed, it undergoes various testing, ensuring the code quality standard. It's specifically from in terms of security. The security testing can be embedded here. Multiple container scanning can be there. So these can be done. Specifically, the tools which can be here could be GitLab CI, Jenkins, which helps automation of certain these testings. So the third stage is container registry. After passing the acceptance, the code is packaged into a container image, and this image is being stored in a registry like Docker Hub, Docker Trust Store specifically, and then image. This Amazon ECR is this another example. So this step makes the container image available for deployment. The final step is orchestration, where Kubernetes comes into play. It orchestrates the deployment and scaling of a container across the clusters of machine, and Kubernetes handles this very well by with the tasks like load balancing, auto scaling, and self healing.
Well, thanks for breaking it down, Amir. So let's let's shed some light on the challenges and advantages of Kubernetes for a business. So Kubernetes comes with several challenges. The major challenge I would call is like complexity. So it has a steep learning curve due to the many components and configurations. And the second, the operational overhead, where managing a Kubernetes cluster requires ongoing maintenance, monitoring, and troubleshooting as well. From the resource management standpoint, the proper allocation and utilization of resources can be challenging, specifically in a large environment. However, Kubernetes has become a game changer in these days. Like you like like in the container world of several reasons. Let's say like scalability standpoint. Kubernetes allows you to scale your applications horizontally, adding more containers to it as needed to meet demand. So this scalability is crucial for large scale applications and services. And coming to the high availabilities, the reason the Kubernetes offers self-healing capabilities, as you mentioned, so ensuring that your application remains available even if some containers fail, so it can automatically restart or reschedule containers to maintain service continuity. And the other element, automation. Kubernetes automation, many aspects of container management, reducing the need for manual intervention. So this automation streamlines deployment and operations, allowing teams to focus on other tasks. And from the multi-cloud support, Kubernetes is cloud agnostic, so meaning it can run on various cloud platforms or on-prem infrastructure. So this flexibility is available for organizations with diverse environments or multi-cloud strategies. And then the last element I would call is like an ecosystem where Kubernetes has a vast ecosystem of tools and extensions, allowing you to customize and enhance its functionality. Whereas, and similarly, it can also use tools like Helm for package management, or like for monitoring. Prometheus are just a few examples I would name. And there are a few other tools like for and on top of Kubernetes you can also implement Argo CD for end-to-end automation and encryption standards.
Yep. So great insight, Elias. And to add to that, the service for service mesh, specifically inter service communication, Istio is one of the tool which is very good for handling intercommunication, inter-service communication. So, what about the use cases where Kubernetes excels? Can you give some examples?
Absolutely. Kubernetes shines in various scenarios. First off, the microservices. It allows you to deploy, manage microservice independently. So this is the ideal for applications with multiple services that need to scale separately. Considering an e-commerce platform, instead of having a monolithic application that handles product listing, user accounts, order payments, and shipping, a microservice approach would break these into individual various services. Product service, which manages the product catalog and inventory, and for the users, from the user service, it handle user accounts, authorization and authentication too. Now, from the order service standpoint, where it takes care of orders and payments, and from the shipping service, it deals with the shipping logistics information. So long story short, the Kubernetes allows these services to run independently, scaling them as needed. For example, during a holiday sale, let's say you can scale the order service to handle increased traffic without affecting other services. Meaning Kubernetes also provides service discovery, allowing these services to communicate with each other seamlessly. For the CI/CD pipeline, Kubernetes integrates with CI/CD tools, enabling automated deployment and testing. Whereas in the hybrid cloud deployment, it supports multi-cloud and hybrid environments, allowing you to deploy applications across different platforms. And the big data analytics, Kubernetes can handle large-scale data processing and analytics workloads, which can provide flexibility and scalability too.
Yep, those are actually the critical and major scenarios, four scenarios which we have covered. And specifically, I think listeners will be getting a good insight why and where Kubernetes is being applied. So we have got these containers. How does Kubernetes manage them across the country, across the clusters?
Gotcha. So that's where cluster architecture comes into play, where in Kubernetes, a cluster is made up of multiple nodes, which can be physical or virtual machines. These nodes are divided into master node and a worker node. When I say the master node, which is responsible for managing the cluster by overseeing the tasks that scheduling workloads and maintaining the desired state. On the other hand, the worker nodes are where the actual work happens, meaning they run the application inside the containers.
Sure. So yeah, that's pretty much it. So we specifically for managing these worker node, kubectl comes into play. So how how these users interact within the cluster. So is there a inter-cluster communication? How that's been possible? Is there a center point of communication?
Oh yeah, the reason the server called API server, the application like programming interface server, where the central communication hub in Kubernetes sits. So I would call it as the heart of the Kubernetes because it exposes a RESTful HTTP API, which allow users to interact with the cluster. So this is where you issue commands or deploy applications, scaling and monitoring the cluster health. So think of it this way. When the command center for everything happening in Kubernetes takes care of, like whenever you want to push anything, whenever you want to have a user, instead of having user interaction, you would interact with an API and then get the thing done, necessary, like a required thing or the task done wherever you need to.
Yeah, so that's interesting. So we have covered inter-service communication, how that is possible with API server. I think we can let's now talk about the pod, the fundamental building block of Kubernetes. They are the smallest deployable unit and can contain one or more containers that share some same network namespace and storage resources. So this design allowed containers within the pod to work together as a single unit, facilitating seamless communication and resource sharing, which is very important in case of any one of the containers is failing, then a resource can be shared there. And when you deploy the application in Kubernetes, we essentially deploy the pod or a group of pod. So uh, how these contain controllers are been working? What about these controllers? How do they fit into Kubernetes ecosystem? Do you want to shed some light on that?
Sure, the controllers are critical in Kubernetes. When I say that, I mean it like, when they manage the desired state of the cluster by continuously monitoring the current state and reconciling it with with what users have defined. Let's say, for instance, there is a replica set which ensures that a specified number of pod replicas are running at any given point of time. Then the deployment helps the manage application updates where it allows you to roll out changes smoothly. Then stateful set is designed for stateful applications where order and persistence matters. So, and also I've heard about the service discovery and load balancing. So why don't you shed some light on these areas?
Yeah, sure. So Kubernetes has a built-in mechanism for service discovery and load balancing, and that's one of the very critical added add-on. So services in Kubernetes act as an abstraction layer, allowing application to communicate with each other, as we have discussed with API server, and without worrying about changing the port IP address. So that's a very critical addition here. This abstraction ensures that traffic is always directed to healthy instance, even though underlying pod has changed. So that can be understood that how the pod is very critical to having their health being checked overall. So specifically, this lead to the next question, that how about scalability? How does Kubernetes handle scaling there?
Well, Amir, Kubernetes excels at scalability, I would say, where it supports horizontal scaling, which means you can add or remove replicas based on the demand needs. So auto scaling features automatically adjust the number of replicas based on resource utilization, which ensures optimal performance again. So this makes Kubernetes ideal for applications with fluctuating low workloads. Suppose so. And speaking of resources, and utilizations, and how does Kubernetes do? Can you shed some light on how Kubernetes manage resources?
Yeah, that's very interesting aspect of Kubernetes, specifically Kubernetes security. RBAC is one of the main addition which Kubernetes does well, and although there has been many misconfiguration which can be happening there, but yeah, Kubernetes offer fine grain control over resource allocation, and you can set various quota, limit the quality of service levels and classes to ensure fair resource utilization and distribution among various workload. So this approach prevents resource contention and ensure the critical application get resources when they need. So Elias, what about networking? I have heard that Kubernetes has a pluggable network model. Can you explain on that?
Sure thing. Kubernetes allows users to choose from various networking solutions through its pluggable networking model. This flexibility not only enables pod-to-pod communication, but also external connectivity too. So when you're trying to define network policies in the manifest of a enhanced security, so you can select the networking plugin that best suits your requirement. So whether it's for communication within a cluster or the external access. So yeah.
Yeah, so I think we can move ahead to the next and the main advantage or main use case of Kubernetes, that is storage orchestration. And Kubernetes offer a lot in this. Specifically, the it has robust storage orchestration capability. It support dynamic provisioning of storage volume, allowing users to create, attach persistent volume to pod. Resources like persistent volume claim, abstract away the underlying storage details and providing the unique interface for managing storage. So this add to the flexibility and abstraction, which is very valuable for stateful application and data persistence.
Right. Thanks for the deep dive, Amir. Kubernetes has a lot to offer. Speaking with that, we conclude the episode of this of CyberGPT Pulse podcast. So I hope our listeners found this discussion insightful. And again, thanks for joining us, listeners. And don't forget to subscribe for more insights into the world of cybersecurity and Kubernetes. So we will further deep dive in container security aspect in coming episodes. So if you have any questions or topics you would like us to discuss, feel free to reach out or leave us a comment. And until then, stay safe, secure, and protect your digital world. We will catch you in the next episode.
Yep. Thanks, listener, for your continuous support.